Hello everyone, welcome to Code Enzyme. In this video, let's discuss this problem binary graded forces. And before starting this video, I would like to ask you to like this video and subscribe to my channel because majority of my viewers have not subscribed to this, and it doesn't cost you anything, but it will help me a lot. So let's get started and let's first read the problem statement. You are given a list L consisting of n binary strings of each of length m. You can do the following operation any possibly zero number of times. Swap two positions li if the same two positions are both 1 and currently li plus 1. So these are the things, like if the below array has a 1, then we can swap the integers. And we need to count the number of different possible li after some moves or operations, and since the answer may be large, we have to print modulo 10 to the power 9 plus 7. So this is the input format, and let's first understand the sample test cases. Like first we have this 101 and 110. So first we have 101 and 110, and we see that so we want to count how many number of different strings we can form with the first array. So if we have 1 and 1 here, then I can swap these two. So 1 is obviously the answer is 101 only, and then I can swap these first two elements, so my answer will be 1011. So these are the two arrays that I can get, so my answer is 2 for this test case. Yeah. Let's just discuss this third test case because the answer is quite large. So 3 5 and 10101. Okay. Let me erase this. So we have 101 10101 and 11100 11100. Yeah, then 00 00111. So if we want to know, like, okay, like how many different strings can I generate from this second array? So obviously we can swap this. So 1 is 11100 only, then I can get 11010, and also I can get 11001. Only there are only these three possibilities, and next I can get and from these what are the number of arrays that I can generate from this top, right? So for that we can simply apply a permutation combination here, like 10101, and I can see that okay, I have a 1 here, I have a 1 here, and from these three arrays I can also get swap these what should I say, these number of this position, right? Because 1 comes here also, and here also. So basically I can actually swap almost the entire array, and here I have 3 1s and 2 zeros, right? So basically I want to find the number of permutations or a number of permutations with 3 1s and 2 zeros. So it is simply equals to 5 factorial upon 3 factorial into 2 factorial, right? This is basic permutation combination from class 12th. I'm not doing anything advanced, right? So 5 into 4 into 3 factorial upon 2 factorial into 3 factorial. So this will cut, and 2 2s are, so the answer is 10. So I think you understand what I did here. If not, you can just rewind this video, and basically I just calculated what are the possible positions of 1, and then I just did the possible number of permutations using this formula. So let's see the approach now. Okay, so from the previous discussion, I think it is clear that we want to find the number of possible positions where 1 can occur. Okay, so I think I don't know how should I explain this on paper, but like, okay, first we can just calculate the number of positions. Like if I have something like 1, let's take a random array, and then Okay, something like this. So if you want to calculate the number of positions, and like if I had 0 0 all zeros, then obviously I won't be swapping anything. But in here, like, okay, I can swap this. If there is a 1, then obviously I can swap it. If there is a 1, I can swap it. But if it is so basically I can swap the entire array, right? So 1 can come in all positions in this second position, right? Second string. So if I can get a 1 in every position, in here also I can get a 1 in every position. So in this entire string can also be swapped in this first one, right? But if there is a case like all zeros, then ones, then I will never be able to swap it. Like if there is a case like 1 0 1 1 0 0, and let's say something like 0 let's say 0 0 1 0 1 1, and only this positions can be swapped. If it is something like that, then what is the possible number of strings that I can get from here is like if these 3 positions can be swapped, then these are checked, right? I mean, I can get a 1 here, so I can swap this. There is a 1, so this. So I think you get the idea. I just need to get the number of positions I can swap, and from these 4 I can say, okay, the total number of combinations will be 1 2 3 4 5 factorial upon the number of zeros and the number of ones. So I think from this also we will get 10. And if this was also checked, then I could have then my answer would be 6 factorial upon 1 2 3 factorial into 3 factorial. So basic permutation combination. I think you get the approach now. Let's just quickly try to code this up. So I will make a new file and put my template. So let's see the input format. First we have okay, test case, and then we have an n and m integers. So n comma m, and let's take the input. Okay, then let's make an array of strings. So string s of n. Then let's take the input. So for I cn s of I. So now the input is complete. After that, what I can do is okay, I need some way to mark my elements where I can swap the elements, right? So I will create a bool variables. So n cross m. So vector of, let's make a vector of booleans. So booleans, and we can call this anything. I will just call it dp. So and this will be an n cross m vector. So n comma vector of bool of size m, and the currently everything is false. Now let's handle an edge case when we have only one in when we have n equal to 1. So if my n is equals to 1, then I will say cout there is only one possible string, that is the current string, and then I will simply return. Otherwise let me zoom in a bit. Okay, otherwise let's now we can traverse from the end of the string. Like first I obviously have to traverse from the end of the string. So I will run a loop, or I should say okay, let's run a loop for j in range m. Okay, if s of n minus 1 I, then I will say dp of n minus 1 I equals to true. So I think you get the idea what I am trying to do here. I am marking every dp as true. I mean every variable that I can swap the element. If my if s of I was true, I think you get the idea what I am trying to do. Okay, now if once I have marked this, I can simply run a for loop, but this time I will run it reverse for. So for I in range m minus 1 to I greater than 0, and let's also run a loop for j to m, because this will traverse in my string. Now one thing I forgot to consider is that what if we only have a 1, like something like my above array is something like this, and what if I have only 1 here and 0 0 0 0 0? Then even if I have a 1 and a 1, then obviously I can't swap it, right? I mean, like if my 1 is less than 2, like I should have at least 2 ones, right? Then only I will be able to swap these elements, right? Or something like I should say 1 0, then only I will be able to swap. If my number of ones in the previous array is less than 2, then obviously I can't make any swaps here, right? So I will handle that case, that okay, let's just count the number of ones. If s of I and j equals to 1, then ones plus plus. And if my number of ones is less than 2, then I will not do anything. I will say okay, continue. Now if I have more number of ones, then only I can then only I can swaps. I can do swaps, right? So now, okay, so now that I am at this stage, I need to check that if I have something like I should have at least one with dp of I check whose check was also true, and I have a 1 here. Like, I mean, like I have already made the number of checks here. Suppose if I have check also here, I have to make sure that okay, dp of I of j of check was also true. I mean, there should be at least a 1 that was swappable, right? I mean, in here I checked that okay, there are some ones in the array, right? But now I have to check that okay, but now I also have to check that there should be some ones that are swappable. So I will say okay, I will run this whole loop again. Let me just copy it here, and then I will also check that and dp of I and j I plus 1 j equals true, or I can leave it here. If this is true, then I can say I will make a bool variable here to check this. Check equals to true, right? Now once this is true, then once this is true, then what I can say is I will run this whole loop again, but this time I will update my dp array. So if this is true, then what we can do is I can say if check if my check is true and dp of I plus 1 j. So if my check is true, I have at least one that was one that was swappable, and my dp of ij is true, then I will set my dp of I and j, I plus 1 j is true, then I will set that my current position is also a swappable. A 1 can come at this current index. Else if my s of I and j is 1, if I have a 1 here, then obviously this index is swappable. So I can say dp of I and j is equals to true, right? So now I got the number of positions that was swappable. Now let's come out of this loop, and now I will simply count the number of zeros and count the number of ones in the top I should say top dp, right? So now I will just simply traverse for I in range m. If dp of dp of 0 comma I, if s of 0 I equals 1, then I will say okay, count underscore 1 plus plus, else count underscore 0 plus plus. So now by this step I got the number of positions that was swappable, and the number of and in those swappable position how many ones were there and how many zeros were there. And now I can simply apply the permutation combination formula, that was the total sum factorial upon count 0 factorial upon count 1 factorial, right? So I can say okay, let my answer be equal to 1, and now for I in range 1 2 equal to count 0 plus count 1, then answer is equals to answer times I, and let's take the modulus also. Now I have to do factorial, so I will have to multiply by inverse modulus, right? In here now I will just take the modern template, This is from GFG. You can also copy it from there. Then let's start with 1, then go to count 0, and answer is equals to answer times mod inverse of I, and also take the modulus. Let's copy this loop again, but this time we will go till count 1, and now I think the answer should be calculated. And let's make an handle here and see if this is working. And we are getting a segmentation fault. Okay, so there were a few mistakes that I made. First thing, this should be equal to 1 because it is not an integer here, so it will take it as a true if we don't write that. Next thing I did wrong was I think it was somewhere here that I think this was 0. This should be 1 because because I have to check how many swappable integers are in the second array, second string, not the first, right? Then only I have to consider this, otherwise not. And the last thing, that these signs should be equal to, otherwise it will not work. So I hope you were able to understand this. Now let's try to submit it and see if it is working. And now that gives us a correct answer. So I hope you were able to understand that, and if you learned something, kindly like this video and subscribe to my channel. And if you want a solution to a particular problem, you can comment down and I will probably make a video on it. And many of you keep asking me for where to practice coding and how to improve. So for them, I just recommend them to solve the CSES problem set, and you can click on this right video where I have made a video tutorial on the problem discussions of the CSES problem set. So thank you guys for watching till here, and I will see you guys next time. Thank you.